Okay, now we're going to take a look and see we might have to use more than one of these rules at a time. Quick refresher. Here at the top of the screen is the product rule. The derivative of y is equal to the derivative of the first function times the second function plus the first function times the derivative of the second function. In the chain rule, which we've been practicing the last few times, the derivative of y is equal to the derivative of y with respect to the inner function times the derivative of the inner function with respect to x. Anyway, we're going to apply this to this function here. Let me get a pen. And, well, let's see, that should work. Here we go. There we go. We're going to call our first function f is equal to x cubed times x squared minus 2 to the fourth power. Alright, this looks a little different than what we've worked for. Okay, we've got a function here. So there's our first function. We have a second function. It's being multiplied. But this second function also has an inner function, the x squared minus 2. So we're going to have to apply the product rule and the chain rule together. Okay, so our first function here is, well, let's call it g for right now. That's the first function. That's equal to x cubed. And our second function here, h, is equal to x squared minus 2 to the fourth power. Okay, so now following the product rule, we take the derivative of g here, because we'll need this first function. That's pretty easy to do. When we come over here to h and get its derivative, we said we're going to have to apply the chain rule. So the inner function is equal to x squared minus 2, and the outer function, the h of u, is equal to u to the fourth. So we'll have to take the derivatives of these two. So we've got du dx is equal to 2x, and dh du is equal to 4u cubed. Now we finish off this derivative here, and we find that h prime of x is equal to, now let's put the 2x times the 4, so it's going to multiply these together. We get 8x, and then the inner function, the x squared minus 2 cubed. Okay, so we have our derivative now for h. So we have the first function and its derivatives, the second function and its derivative. So now we can ready to write the derivative of f. So the derivative of f of x is equal to the derivative of the first function, the 3x squared, times the second function, the x squared minus 2 to the fourth, plus the original first function, which was just x cubed, times the derivative of the second function. Let me go ahead and write that out. So that was 8x x squared minus 2 cubed. We'll close the paren. Alright, now we'll scroll this down. Okay, so let's clean this up a little bit. So f prime of x is equal to 3x squared minus 2 to the fourth we can put this 8x and this x cubed together, so we got 8x to the fourth times x squared minus 2 cubed. Yes, with a little extra effort we can put these together. We have an x squared that's common, and this inner function, we have a cube of that. So we could write this as x squared times x squared minus 2 cubed times 3 plus, wait a minute, I left something out, 3 okay, so if that's cubed, that leaves one of those x squared minus 2 still in there, plus 8x squared. Clean that up a little bit. Let's see. We have x squared minus 2 cubed. Now we've got 3x squared minus 6. We can add that to the 8x squared, and we have 11x squared minus 6. I think that's as far as we need to take it. That looks pretty good. Anyway, so here we finally have the derivative. Let's write this in here. So starting with our original function up here, f of x is equal to x cubed times the quantity x squared minus 2, that quantity to the fourth power. That turns out the derivative of that is x squared times x squared minus 2, that quantity cubed, times 11x squared minus 6. Okay, let's do another one. Now, we've seen in the Khan Academy videos, you saw where they used the chain rule to do the quotient rule. Okay, we'll have an example of this here. So, f of x is equal to x over the square root of x squared plus 1. Let's scroll down, get more to the top. Okay. Well, we could rewrite this function as x times x squared plus 1 to the negative 1/2. See, this was in the denominator, so it's a negative. Exponents, the square root, so that's a 1/2. And now we have it, again, as a product rule and chain rule. Okay, so the first function, well, it's just x. That's pretty simple. The derivative of x is just 1. So that's going to make things pretty simple. Now our second function, h of x, is equal to x squared plus 1 to the negative 1/2. Okay, we have an inner function, the x squared plus 1, and the outer function, we'll just rewrite h, make it h of u, is equal to u to the negative 1/2. Okay, let's take those derivatives. Du dx is equal to 2x, and dh du is equal to negative 1/2 u to the negative 3/2. Alright, now finish off the derivative for h. So we're just still doing the second function here. So this is the derivative of h of x. Okay, so this times this. Let's see, can we put something together? Negative 1/2 times 2 is negative 1. So we have a negative x here. Okay, we have the inner function, the x squared plus 1 to the negative 3/2. Alright, let's leave that on the outside for a moment. Okay, let's put these together now. So we're using the product rule. So the derivative of the first function, the 1, times the second function, which was the x squared plus 1 to the negative 1/2. Okay. Plus the first function, which was just x, times the derivative of the second function, which is negative x squared plus 1 to the negative 3/2. Alright, now time to clean this up. It looks pretty complicated. So the 1, okay, that doesn't matter. We've got the x squared plus 1 to the negative 1/2. Putting this together. Okay, we don't put the positive x times the negative x. We get negative x squared times x squared to the plus 1 to the negative 3/2. Okay, well, let's just finish that up then. We can clean this up by taking that x squared plus 1 to the negative 3/2. Okay. So that would make this x squared plus 1. Okay, now by taking this x squared plus 1 to the negative 3/2, we're going to take it out of this. Well, I know it doesn't quite look like that, but this leaves an x squared plus 1, whole one of those, minus an x squared. Now the reason I wrote it this way is, well, these x squares cancel out. All I have left is 1 on top, and then x squared plus 1 to the negative 3/2. No, not to the negative 3/2. When I put it on the bottom, the negative goes away, right? So, it should be 1 over x squared plus 1 quantity to the 3/2. And that's it. If you don't quite believe it, then you can go back and use the quotient rule and see what you end up with. But I believe you'll end up with the same thing. Okay, well, that's all for this video. We'll see you later.